Everyone. In this class, I'm going to discuss about multiplexer, demultiplexer, encoder, and decoder. First one, multiplexer. A multiplexer is a combinational circuit which has multiple inputs and single output. So, no matter what are the number of inputs, the number of outputs are going to equal to 1. Whether it is 2:1, 4:1, 8:1, and 16:1. Like the number of inputs are equal to 2 to the power of n. That means it is the 2:1, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Likewise, we can move to anything. Those are inputs. And the number of inputs are different, but the number of output is always 1. Relationship between the power of number of select line and the number of input is following. 2 to the power of number of select line is equal to number of inputs. For example, 2 to the power of 3 selected line. So there are 8 inputs. So this equation is very important in order to find the number of selected line and number of inputs. Now I am going to implement a multiplexer, and that is 8:1 multiplexer. Before that, we can see the block diagram of the multiplexer, and here's the truth table, and this is the basic circuit of the multiplexer. Now I'm going to implement the 8:1 multiplexer. First, we want to choose the multiplexer, and this is, you can see, this is 2:1 multiplexer. Here 2 wire connection and here 1. So now I want 8. So here I want 8 wire connection. So first select this, and I want to select the bits as 3. Data bit is equal to 1. Then here we can see 8 cell lines. You can arrange it in any way. That's not a problem. Then I connect the output and the LED also. And here I want to connect the input for all wire connection. And I connect the another input for this select. So here I can see a error that incompatible bits. Here you can see 3 and here 1. So I want to change it as 3 bits. Now okay. Now I will tell you how it is work. First, I'll choose some number bits like this. Now I'm going to tell you what is the usage of this. Here you can see all are 0. Now please watch clearly. I select the first digit as 1. Now you can see the change in here, 0 and LED is off, because we get the output for this line, because this is 1. So this is the first level. This is 0th level. This is first level. And this is second level. This is third level. This is fourth level. And this is fifth level. This is sixth level. And this is seventh level. So totally, when you can see, this is 1. This is 1 plus 2 is equal to 3. And this is 7. You can calculate this. Calculate this. I show you. 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2. Now here all are 1. So I can write that like 1 plus 2 plus 4. So the final answer is 7. Here 7, and here this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Ignore my handwriting. This is 5, this is 6, and this is 7. Now let me check. Okay. So now you can understand easily. Here, 0th level, I have 0 here. So the output is from this way. And when I select 1, you can see here 0. Now I showed you, I changed this first level as 1. And here LED is on and the output is also on. Likewise, here now 3. You can see here 0. So LED is off and the output is also 0. Now this is 2. Here 1. So that's why I get LED as on and output as 1. Now here I'll check 0th level. Sorry, 6th level. Here also am I right? No. This is 2 to the power of 0, 1, 2. This is 4th level. And this level. Then this is 5th level. So 0. And this is 6th level. And this final 7th level. You can see the change. Okay. I think you can get it clearly how it is work. Now I can move to the demultiplexer. Demultiplexer. This is opposite to multiplexer, and multiplexer is also called as MUX. So we can call demultiplexers as DEMUX. In multiplexers, we have so many input and one output. In DEMUX, we will send only one input and get so many output. So this is one to many. By applying control signal, we can steer any input to the output. Let's check whether it's working correctly. So this is the basic diagram of the demultiplexer. Now I can check the truth table here. So first D. I put D as 1, then I'll change the input. So here, when S1 and S0 is equal to 0, we get the output as D in Y node. You can check it here clearly. Here I have 1 here and Y node, for I get 1. Then I'll change S0 as 1. Then now the D is changed into Y1 as 1. Now I change S1 as 1, S0 as 0. Now here you can see why I put D here. When I off the D, all are 0. All are comes to 0. For all the things, when D is 0, the all outputs are should 0. So the D is when on, we can see the change. Here S1 and S0 is equal to 1. The Y3 is equal to D. So it's working correctly. Now encoder. Encoder is a combinational circuit which converts 2 to the power of n input into n outputs. We can use encoder in communication, coded signal transmitter. Here we can see 4 inputs and 2 outputs. So it's called as 4 to 2 encoders. And here's the truth table for encoders. Now you can see here, when D0 is 1, here we get 0 for both Q1 and Q2. When D1 is 1, we get 1 for Q2. Then when D2 is 1, we get 1 for Q1. Then we put 1 for D3. We get both Q1 and Q2 as 1. My mistake, I want to change this as 0. That's not a problem, but I changed it as 0. It's my mistake. Here is the logic circuit for the encoder. Now I'll move to the whiteboard to show the truth table and then how to draw the circuit for encoders. So here I'll write 0, 0, 0, 1, and next D1 is only 1. Then D2 is only 1. Then D3 is only 1. And here for Q1, 0. So next condition, only Q0 is equal to 0. For third condition, only Q1 is equal to 0. Fourth condition, both are 1. Because this is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2, and this is 2 to the power of 3. You can observe it here 0, 1, 2, 3, and here we can add those. Here this is 0 and this is 1. This is 2. How can I say it is 2, 1, 0? So 2 to the power of 0, 2 to the power of 1. So 0 plus 2, the answer is 2. From this way, this is 3. This is the way to fill the truth table for encoders. Now, I am going to write the expression for Q0 and Q1. First, Q1. When we get 1 for Q1, here D3 is 1 and D2 is 1. So, I'll write D2 plus D3. For Q0, D1 plus D3. By using this expression, I can draw the circuit. So, here first, I'll take D3 and second D2 and third D1. So this is the OR gate. For Q1, I can add those D2 and D3. This is Q1. And for Q0, D1 plus D3. So it is Q0. So this is the circuit diagram for the encoder. You can see it here also. Now move to decoders. Decoder is a combinational circuit which is inverse function of encoders. A common type of decoder is the line decoder, which takes an n-digit binary number and decodes it into 2 n data lines. So the relationship is n input into 2 to the power of n output. Decoder is a multi-input and multi-output logic circuit, which will decode n number of input into 2 to the power of n number of output. So n into 2 to the power of n. So when is the input is equal to 2, output is 4. So now we can see the truth table for 2 to 4 decoders. So this is the inverse function of the encoder. So here you can put it easily. This is one, and here this is one, and here sorry, I'm done a mistake. This is 0th level, so I want to put this as 1. Then this is 1, this is 1, and because this is 2 to the power of 0, this is 2 to the power of 1, this is 2 squared, and this is 2 cube. So this is 0, 1, 2, 3. That's the way you can fill it. At a time, only one output will be enabled in the decoder. This is the main point. So you can check it here. At a time, only one output will be enabled. So now here, for D3, I'm going to write the expression. D3, A0 into A1. For D2, A0 into, sorry, A1 into A0 bar. You can write it as A0 into A1, A0 bar into A1. Both are same. Then D1, A0 into A1 bar, and D0, A0 bar into A1 bar. By using this expression, we can draw the circuit for decoder. So this is the block diagram for decoder. You can see this is a 2 to 4 decoder, 2 inputs and 4 outputs. Then this is the truth table, as I show you in the whiteboard. Then this is the circuit. You can draw it in Logisim. Then move to the 7-segment display decoder. 7-segment display is used to display numbers from 0 to 9. This display has 7 segments. According to the inputs, the display is high, the corresponding segment. This is also a decoder. So this is the truth table for the 7-segment. I showed you because 7-segment is the biggest circuit, so we can't draw it easily. So this is a simple way. By using truth table, we can change the output as our wish, not our wish. Following this, we want to follow this as in order. So we can click it and change it. After that, we can build circuit. I'll show you in the Logisim how to draw the 7-segment circuit. Now here, I want 4 input and 4 output. So I must put it, and I want to name it also. First, I'll copy this. and I want 7 output. And don't forget to rename it perfectly. This is D, this is E, and this is F, this is G. Now, in project, click Analyze Circuit. You can see here, as the input, I named the labels as A, B, C, D, and outputs also like this. Then click Table. You can see all outputs are crossed. Now, I'm going to put the outputs in order. So now, put carefully because a small change can change the whole circuit. So for the first, G is 0 and others are 1. You can see first here cross, then when we click the cross, we get 0 and another click we get 1. Like this, we can change 0, 1, 1, 0, 0, 0, 0. Next one is 1, 1, 0, 1, 1, 0, 1. Fourth one is 1, 1, 1, 1, 0, 0, 1. Next one is 1, 2, 3, 4. Next 0, 1, 1, 0, 0, 1, 1. Next 1, 1, 0, 1, 1, 0, 1. Next one is 1, 0, 1, 1, 1, 1, 1. Then 1, 1, 1. Others are 0. Next one, all are 1. Last one is check this twice. First one is okay. Second one is okay. Third one okay. Fourth one is okay. Next okay. Next one is 1, 0, 1, 1 0 1 1. Okay, next one is 1 0 1. That's a 1. Okay, then click build circuit and then click OK. Now you can see the circuit for the 7 segment. Now create a circuit called as 7 sec. Next step is you want this whole circuit as a sub-circuit for this 7 segment canvas. Then just click in main segment and you can see the box here with the mouse and just put it in the drawing canvas in the 7 segment sub circuit page. Now you can see here 4 inputs and 7 outputs. Move to the next step. So you can see in this picture, as like this, we want to join this sub-circuit with this 7 segment. So I want to get the 7 segment here. This is the 7 segment and I want 4 inputs. A, B, and make copy and paste. Then C, D. Now the first output is moved to this one. Okay. The second output is going to this. Then, oh, a mistake. Okay. Done. Then next one, I'll change the line way. The next one is goes to here. Okay. Then okay. This is the last one. Okay. Then here you can see 0. Now I'll change it as 1. Then this is 2. You can see 1 0 is equal to 2. Then this is 3. Then this is 4. And this is 5. And this is 6. And 7. Because 1 1 1 is equal to 7. Then I'll move to the 8. Then this is 9. Likewise, this is working properly. And now you know how to draw the 7-segment circuit easily, and how to run the 7-segment circuit properly. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I think you can get it easily. And this is the last discussion of this series. See you in next. Until